Alright, in this video we're going to be working some multivariable calculus relative extrema problems. Okay, and so the first three are like just kind of look at it and figure out where are the local extrema. And so I'm just going to start with those. One is equals 1 plus x plus 2 squared plus y plus 3 squared. Square root. All right. And with this, I can tell that the very least that this is going to be is the square root of 1, right? When this is 0 and that's 0, it's an absolute minimum. But the least that this square root can be is equal to 1. So that's going to be a local minimum at the point where x equals -2 and y equals -3. And, well, I also know what the z coordinate is going to be, because if both of those things, if x is -2 and y is -3, then z will be the square root of 1. And, well, that'll be what I have there. Okay, that's all we're asking for right there, is determine the location of the minimum or maximum. Okay, the second one, I think this one's also pretty obvious. Z equals 5 minus the absolute value of x minus 1 minus the absolute value of y minus 2. Okay. This one? Yeah, you're cool. And again, the least that these absolute values can be is 0. So if x was 1 and y was 2, I'd be taking 5 minus 0 minus 0. And I can't, I can't subtract, or I can't add to 5, right? These absolute values, they can't be negative. So I'm going to say that there's a local maximum at the point where x is 1 and y is 2, and that will give me z equals 5. Okay. And if you're interested in what these types of graphs look like, you should go on the internet and Google 3D Grapher and look at GeoGebra, or look at Wolfram Alpha, or use the new Google technique. Although I did try to graph one of those last week, and it did not give me a picture of the graph. It was an x and y type input, and it didn't give me a picture. So I don't know if that's an issue with my entering it into Google or what, but it doesn't seem like that's 100%. So number 3, z equals x squared plus y. Oh yeah, okay. This one is going to require a little bit more work. I'm going to have to complete the square, but it will probably be less work than it would be if I did the second partials test. Minus 6y plus 10. Okay, so I'm going to do some completing of the square here. I'm going to kind of collect all the things that have an x in them together. So I'll have z equals x squared plus 2x, and then I'm going to leave a blank to add something else. Okay. Actually, no, I'm not going to. I'm going to turn this into a perfect square by dividing this in half and then squaring it, so it's 1 squared is 1, plus, in this case, y squared minus 6y plus. Okay, let's look and see. I've got dividing -6 by 2 is -3. We square -2, and that's 9. And look, oh, that's exactly the 10 I had. So this is all I need to do. I don't need to account for the fact that I added 1 and 9 by subtracting anything, because it was already what I had there. So this is x plus 1 squared plus y minus 3 squared. And, okay, so we know what this is going to look like. This looks like kind of one of our soft cones, and it's just moved. It's translated over to the left by 1 and out by 3, if y is the in and out direction. So I'm just going to say this one's got a local minimum, because the least of these square numbers can be is 0. So I'm going to say local minimum at the point where x is -1, y is 3, and z would be 0 in that case. Okay. Number 4, use the second partials test. Yeah, this is probably what we're expecting. It's going to be all right. Those things are tough. Oh, but yeah, you can't afford another binder spill. No, you can't.
Things are just not going my way.
Things are going to get better, man, I promise. Okay, so I'm going to take f of x and y equaling x to the third. Oh my goodness, a lot. Plus 3x squared minus 9x plus y squared plus 4y minus 1. Okay, well, we can do this, I guess. And I'm going to have, all right, so I'm going to take my partials. Fx equals 3x squared plus 6x minus 9. And that's it, because all of these things are constant with respect to x. Fy equals 2y plus 4. Okay, so if I'm looking for the places where both fx and fy are 0, I mean, you could start with this, you could factor it, you can find some or some x values. But I think, oh no, we are going to have to do that, pardon me, I was thinking about something completely different. I was thinking we could solve for that and then plug back in over there. And so I'm going to say, okay, well, if fy equals 0, then that gives me y has to equal -2. And if fx equals 0, well, I'm going to need to do some factoring. So it'd be 3 times x squared plus 2x minus 3, that equals 0. Okay, we're going to be able to solve this, right? It's not too bad. So it's 3 times x plus 3 and x minus 1 equaling 0. So that gives me x equals -3 from this and x equals 1 from that. That gives me nothing. And now I've got my coordinates, right? I've got 1, -2, and -3, -2. And I'm going to run the second partials test. Okay. Now, I need more paper. I need to zoom out as well. Let's try both of those things. Yeah, I think we're going to need that. Okay, so I need my second order partials. Fxx is equal to 6x plus 6. And then fyy is equal to 2. Okay, that's going to be helpful. And then fxy is going to be 0. Okay, so I'm just going to have that there. So to get for, like, maybe I'll mark off, this is going to be where I'm going to do 1, -2. Get that pen going. So at the point where x is 1 and y is -2, I'm going to have my determining number equaling fxx is 12 times fyy minus fxy squared. That's positive, so I know I have an extremum. Okay, fyy is positive, so I know it's going to be a minimum. fxx is also positive, which is also telling the same thing, but I know since that's positive, I know okay, it's going to be a minimum. And then at the point where x is -3 and y is -2, okay, my determining number is going to be fxx is going to be -18 plus 6 is -12 times fyy minus fxy squared. This is a negative number. I know that that means I've got a saddle point here. Okay. And then I will get a new sheet of paper and start in on the next one. So if x and y is x to the 3, 6xy, sounds a little annoying, minus 3y squared plus 1. And so I'm going to take my partials. Fx is going to be 3x squared plus 6y. Fy is going to equal 6x minus 6y. All right, now this is actually nice because I know if fy is going to equal 0, then x and y have to be the same number. Okay, so then I'm going to go into fx equaling 0 and probably on y, right? It really doesn't matter, you're going to have the same thing, but okay, that gives me 3x squared plus 6x is equal to 0. And, well, I'm going to say that that happens at, I just need to factor, I guess, 3x times x plus 2. Yeah, that's at x equals 0 and x equals -2. And we already know that y equals x, so I'm going to need that. Oh, thank you. Okay, now I'm going to get my second order partials. Fxx equals 6x, fyy equals -6, and fxy is looking like +6. Okay, now I'm ready to go. I've got my pairs. Okay, at 0, 0 looks to me, okay, yeah, so my determining number is fxx is 0 times fyy minus 6 squared is negative, so that's a saddle point. At the point -2 and -2, I'm going to have my number equaling, I'm going to have it, okay, x is -2, so fx is -12. -12 times fyy is -6, so that's positive 72, minus fxy squared is 36. If I take 72 and I subtract 36, I get a positive number. So that's an extremum. And then I can check fyy, you know, fxx is going to have the same sign, but fyy is pretty clearly going to be negative, so I know that that means a maximum. Okay. I think I'm going to have time to do one more in this sitting, and then I guess I'm going to have to be recording the rest of these separately after school, I guess. But that's all right. I can do that. So fxy is 2x squared minus 4 times x times y, add y squared, add 8x, subtract 12. Alright, so I'm going to take my partials. 4x minus 4y plus 8. Okay, it's going to be alright. Fy is -4x. Okay, plus 2y and 0. Make sure I didn't copy that problem wrong. I was hoping I did copy that problem wrong. I did not. Squared plus 8x minus 12. Okay, whatever. All right. Now, on this, if you are trying to choose like which one to set equal 0 to isolate one of the variables and substitute on the others, I'm going to choose this easier looking one, right? Because if I solve for x over here, it wouldn't be a big deal. But I'd have two things to sub in on each x, which I mean, would be a huge thing, but I'm going to just choose this one. I'm going to say fy equals 0 gives me y equals 2x. Yes. Because I would add the 4x over, I'd have 2y equals 4x, divided by 2, yeah, y equals 2x. Okay. Then fx equals 0 gives me 4x minus 4y. 4y would be 8x plus 8 equals 0. Okay, we can work with this, right? We can say that's negative 4x plus 8 equals 0. That gives me x equals -2. Y equals 2x. So y is going to be equal to -4. And, well, luckily for us, we only got one critical point, so that's going to be good. Okay, yeah, that could have been way worse. So I've got my critical point. I need my second order partials. fxx equals 4. fyy equals 2, and fxy is looking like -4. Yeah. Meaning that, well, we just, if I'd known that, maybe, I don't know if you're watching, maybe the strategy should be to take the second order partials first, because you can know, well, I guess you'd still have to find the coordinates of the critical point. But all I'm saying is, like, you know, I know that if there's an extremum, it's going to be 8 minus 16 is -8. So, like, it's going to be a saddle if I've got an extremum. So I guess if you were looking for maxes and mins and you found that this was happening and that fxx fyy minus fxy squared was going to be a negative number no matter what, you would know you wouldn't have any extrema. You'd only have saddle points. So I'm just going to say at the point where x is -2 and y is -4, the number that determines the type of thing I'm looking at is going to be fxx fyy minus fxy squared. So I got 8 minus 16 is negative, meaning I am sitting at a saddle point. And yeah, that's going to be all for this video, because I'm going to have to just start recording again this afternoon after school. And yeah, I'll do 2 more of these second partial test ones, a point on the paraboloid closest to the point, and then some contour map examples. And it should be exciting. All right, so, you know, stay tuned for that. But thanks.